This is Unit 3, Lesson 5. So we're going to perform translations on the coordinate plane. This video will cover the vocabulary. So again, make an index card for each term. Write the term on the front, definition, characteristics, diagram, if you can, on the back. Apologize for this grid not coming out 100% here. All right, so you've seen this topic in 8th grade. Again, we're going to review doing it on the coordinate plane before we move off of the coordinate plane. So a translation is a rigid motion where every point in the figure is moved the same distance and direction. Okay, because we're on the coordinate plane, that could mean up or down, right or left, right, or a combination of both. Another way to describe a translation is a slide. We are kind of sliding the figure around. Right? And on the coordinate plane, the rule that you will see to describe the translation looks like this: capital T with subscripts x, comma, y. The x indicates whether to move left or right, and the y indicates whether to move up or down. Right? If we are off the coordinate plane, again, we're going to focus more on that in our next lesson, but I do want that on your same vocabulary card. The direction and distance that is communicated to us is through a vector, and we'll discuss what a vector is below. So a translation preserves orientation. Again, the only transformation that does not preserve orientation is a reflection. Right? So again, the order of the points is kept the same. And parallelism is also preserved. So for example, if I look at this segment here, which corresponds to this one in the other triangle, those lines remain parallel with the slide. The slopes of the lines are kept the same. Right, so a term you may or may not be familiar with is the term vector. This is a ray that has both length and direction, meaning it tells you how far and in which direction to move a point. Typically, a vector is off the coordinate plane, but we could draw vectors on the plane as well. So I connect a pre-image point to an image point, and the arrow indicates the direction. Great. So the starting point of the vector is called the tail, and the direction in which it is headed is called the head. And we name the vector the same way we name a ray, with the endpoint first, and then extending through the direction it's going, where it's headed. Right? So for example, in this diagram, we have a vector that would be considered vectored AB. It starts at A, it is extended or headed towards B.